heat is generated, due to the molten flux becomes short circuit the arc, and then heat is generated due to the ohmic heating of the slag. So, then slag circulates and the molten circulates within the zone and the melt the consumable electrode, and basically finally, it is join the workpiece edges. So, if we look into this figure, that we use the electrode wire and the power supply, that means to make is the electrical circuit, the guide tube also there, and that actually wire, electrode and guide tubes, the flux making this thing and produce the molten. This in this case, the advantage is that it produces the molten slag, and then indirectly that molten slag is actually produces the weld pool. So, in this case, if we look into the main advantage of this, that high deposition rate is possible, even also welding of the very thick plates also possible. The slag consumption rate is typically low, and low distortion is possible in these processes. That means, the electroslag welding processes is almost the similar kind of advantage of the submerged arc welding process. But if you look into the other aspects, this thing, the disadvantage point of this thing, first point is that this process can be done only over the in the design specifically for joining of the in the vertical position of the plates. Basically, when you keep the vertical position of the plate and then keeping two plates as a vertical position, and then from the bottom plate we just keep on welding, and the electrode is basically simply keeping upward direction, and then upward direction, and at the consequently it make the welding in the back side. So, that this process is specifically advantageous for joining of the two vertical plate, and in the large scale, that means large volume of the molten pool is required. In this case, this process is more suitable. So, apart from the electroslag welding process also, there are other welding process, that is the most simple welding process, that is called the carbon arc welding process. It is a very oldest welding process. Seals may be used for the weld pool protection depending upon the type of the melter. So, shielding can be used also, that means either natural gas or flux can be used in these processes, but the basic principle of this process is that power same as the other welding processes. The workpiece power supply, the arc is created between the workpiece and the electrode using the non consumable carbon electrode, and it produces the weld pool. And in this case, if you see that non consumable carbon electrode is basically used, and that this process has been developed long before than the other processes. So, but if we typically look into the advantages of this process, is the first is that low cost of the equipment. So, simply you can use the non consumable carbon electrode, and shielding can also be done either flux or maybe we can use the natural glass. So, in this process, that is one of the advantage is that low cost of the equipment, and therefore, not required very high operator skill is not required, and this processes can be easily automated, but because this process is not very complicated and low distortion of the workpiece can also be achieved, since this is one of the oldest welding process. So, that it is a very simplified way can be applied, but definitely if we look into the very precision of the welding process, in the sense less defect and other way try to produce the less amount of the defects, probably then looking into that aspect, the other welding processes has been better choice as compared to the carbon arc welding process. But precisely looking into the disadvantage of this process, that is that mainly the quality of the weld joint. So, in terms of that, it is not suitable for the when you try to expect the high quality welding joint processes has is already there. But one point is that the carbon of the electrode actually contaminates the weld material with making the formation of the carbides, because since carbon is acting as an electrode. So, at high temperature there may be the possibility of the transfer of the carbon atom, and that creates the carbides in the workpiece material. So, if it is the requirement of to produce the any carbides on the workpiece material, probably in that sense this welding process is more suitable as compared to the other welding processes. Now, the most usable, another one of the most usable welding process, that is gas tungsten arc welding process. In this process we use that non-consumable electrode, and of course non-consumable electrode, but with or without any extra filler material can be added in this process, and sealing is done generally argon, helium or nitrogen, that means one type of the inert type of the gas, and specifically used for this process when it is a very thin section or very small weld joint is required. In this case the gas tungsten arc welding is a good solution. Now, if you look into this from the figure, that power supply is similar to other welding processes. Between the arc can be created between the non-consumable electrode and the workpiece material. Shielding gas is required, and the filler rod may or may not be used depending upon the application. So, the non-consumable stuck through the along with the non-consumable electrode, that there is a the passes through the nozzle, and the also the shielding gas also passes through the nozzle. So, this is the maybe without using the any kind of using the non consumable electrode, this is the one of the most simple simplified welding process, but more usable welding process in the sense that it is having the typical advantages, that since there is no need of using some consumable electrode, or if there is no need of use any filler material. So, only by supplying the heat and fusing these two material. So, material composition is almost close to that of the parent material, but of course, the nature of the solidification behavior of the specific material, that may be bring some structurally different from the base material, but composition may be the same. Relatively high quality welded structure can be possible. So, no slag formation as compared to the other welding process, since we are using only the shielding gas and it may not become part of the final weld joint. So, thermal distortion of the workpiece can be minimized, because the heat can be concentrated in a very small zone as compared to the consumable electrode like gas metal arc welding or shielded metal arc welding process. So, in general the shielded metal arc welding or gas metal arc welding process, definitely the concentration of heat depends on the size of the electrode, but in that sense the size of the electrode can be controlled in case of gas tungsten arc welding process, that can be done the different shape of the nozzle tip, and accordingly heat can be concentrated, and of course, in other it also depends on the shielding gas flow rate also. So, in that point of view, that the gas tungsten arc welding process is one of the most widely used welding process, specifically when you try to join is a very thin metal and there is a no need of any filler material. But disadvantage is that low melting rate as compared to the other welding when there is use of consumable electrode, relatively expensive as compared to the I can say that carbon arc welding processes, and it also requires high level of the operator skill. That means, to maintain the arc gap or to move the torch, then high operating skill is required to get the successful weld joint from these processes. So, apart from gas tungsten arc welding process, we can look into the other aspects of the gas tungsten arc welding process. One thing is that workpiece in a protective inert gas, workpiece remains in the protective gas atmosphere, and next is the any filler material is used which can be used externally. So, there may or may not be required any filler metal, or maybe filler metal may not be the part of the main welding system. Sometimes to increase the melting rate, melting point of the electrode. So, that since in this process we use the non-consumable electrode, its objective may be to increase the melting point of the electrode, and that can be done using the thorium or zirconium. Zirconium is added to the tungstens that actually that is basically useful or helpful to retain the hot hardness even at very high temperature. So, in that case we generally use 2% thoriated tungsten electrode in gas tungsten arc welding process, just because of that for this material the melting point is very high. So, that it will try to reduce the wear of the electrode at the very high temperature or melting of the electrode. But in the when you try to look into the that we can see that is the electrical circuit is there, power supply, and then here workpiece, and that it creates the circuit. So, whether the electrode, what should be the polarity of the electrode, that can also be changed in gas tungsten arc welding process. Normally DCEN, that means direct current electrode negative, is used in this case, but of course depending upon the application direct current electrode positive can also be used, or AC current can be used instead of the only of the DC current. Normally welding of the aluminum and magnesium and their alloy, normally AC current is preferred, because alternating current is make the cleaning action in the half of the cycle during the welding of this material. So, there is a continuous change of the polarity positive and negative when we use the AC current. But typical point of this process is the most usually shielding gas is the argon material, but sometimes use the nitrogen for welding of the copper material. So, these are the typical characteristic or typical points that is related to the gas tungsten arc welding process. Now, we look back to the another arc welding process, that is called the plasma arc welding process. Here if you see that plasma arc welding process, it is always try to take the advantage of the gas metal arc welding process, almost similar configuration. That means, they use the non-consumable electrode, creates the electrical circuit, but here we can use the another extra shielding gas, that is called the plasma gas, basically that actually creates the arc and maintains the arc, and that actually helps to melt the workpiece material. So, with respect to the gas tungsten arc welding process and all the general components of the gas tungsten arc welding process, here the addition of the extra plasma shielding gas. But let us look into this figure, how this process has been developed, the plasma arc welding process. Here we can use the DC power supply and create the positive and negative, and here non-consumable tungsten electrode we can use here, and shielding gas also supplied, but inside there is a plasma gas also be supplied here. So, basically passing through the electrode, there is the current when passes through the electrode, it creates the pilot arc, and then after that it creates the arc due to the passing of the plasma gas, and then high temperature has been created, and finally it creates the plasma arc between the nozzle tip and the workpiece material. So, what is the advantage of with respect to the gas tungsten arc welding process in case of plasma arc welding process? In general, the position of the electrode or torch of this plasma arc welding process can be designed in such a way that it can produce the very constricted arc as compared to the gas tungsten arc welding process, because gas tungsten arc welding process the arc is created between the workpiece and the electrode tip of the electrode. So, depending upon the tip of the electrode, the shape of the arc can be decided mainly, but in this case apart from the electrode tip, there is the plasma gas is the main gas that actually creates the arc between the workpiece. So, that plasma gas, application of the plasma gas can be constricted in a very small zone. So, that is why very constricted arc can be created using the plasma arc welding process. So, even from on the other welding on the arc welding process, only in the plasma arc welding process it is possible to produce the keyhole mode, that means high depth of penetration can be welded using the keyhole mode plasma arc welding process. So, here if we look into that typical points of this arc welding process. First is the what is the plasma? Plasma is the basically gaseous mixture of positive ions, electron and neutral gas molecules, and that plasma gas is actually create the arc between the workpiece and electrode material. And here also like GTAW, here we use the non consumable electrode, but specific advantage is that it is a good tolerance of the arc to misalignments. If there is a misalignment, it can be adjusted by the creation of the arc, and high welding rate can also be done in plasma, and keyhole effect can also be produced. This is the only arc welding process where keyhole mode effect can be produced, and that actually penetrate is the high penetrate in the for high thickness material. So, these are the typical advantage, but other advantage of these things, plasma arc welding can also be nowadays the plasma arc welding can also be developed in the microplasma range, in the sense that is called microplasma arc welding processes. So, such that the electrode current that welding current can also be reduced to less than 10 amperes, and even it is can be controlled even for the in the range of the milliampere. So, with this controlled arc, with this controlled current, the arc can also be controlled in even in the module of the pulse or continuous mode, and that small amount of the application of the current here, that means indirectly it is basically it can controls the heat input, and that heat input can be created in a very small amount, that may be suitable for the any kind of micro welding processes. So, that development has been done also in plasma arc welding processes. That is the another advantage of this process, you can say. But in terms of the disadvantage, that expensive equipment as compared to the other welding process, that of course, the expensive equipment is a relative term here. Probably this is expensive equipment as compared to the gas tungsten arc welding process. But high distortion and wide weld as a result of the high input. If there is a requirement of the high input, then it can produce the high distortion, and maybe wider weld pool can also be produced. But the width of the weld pool is more controllable in plasma arc welding process as compared to the gas tungsten arc welding process. Now, normally plasma arc welding process, two modes of the plasma arc can be used in the arc welding process. One is the transferred arc, another is the non-transferred arc. So, transferred arc means it is a simple way the creating the arc between the workpiece and the electrode material. So, that workpiece being welded, and it becomes the final part of the electrical circuit. Plasma arc transfers from the electrode arc, basically arc creates or arc transfer from the electrode to the workpiece material, and that can be done is a very high speed of welding. So, this is the normal mode of the plasma arc welding process, that is that we say that transfer arc, it is like a gas tungsten arc welding process. It is a simple way the creating the arc between the workpiece and the electrode, but other way also it can also be developed, or it is developed in the another mode of the electrode arc welding, that is called the non-transferred arc. So, non-transferred arc is basically arc can be created between the electrode and the nozzle. So, basically nozzles becomes the part of the electrical circuit here to complete, and that generate the heat. That heat can basically creates the molten of the workpiece material. So, in this non-transferred arc, basically high temperature is carried out to the workpiece by the plasma gas, and this is in this case the thermal energy transfer mechanism is basically like the almost similar to the oxy-fuel where mode of in oxy-fuel welding process, or maybe oxy-fuel transfer of the in oxy-fuel welding process, what way it transfer the or it generates the heat. So, Basically, the non-transfer arc is mainly used for the welding of the various materials, but it's a can be used as a for the thermal spraying or making the coating of the surface. This non-transfer arc is more preferable. So, that is why this is another development of the plasma arc welding process. So, using the non-transfer arc basically create the coating process than welding processes.